In question 6, we are working on testing the variance between two populations. In this case, we've got donors to a PBS station, men and women, and we want to test whether the donation amounts have greater variability for men than for women. And we're given some sample results here. So we've got X bar and S, and we need to calculate the variance for two populations. We would use the F test. If you recall, that's the ratio between two chi-square values is what it essentially comes out to be. But in this case, we need to say, first, what are the null and alternative hypotheses statements? Identify the degrees of freedom for the numerator and for the denominator, and the critical value for F. So those are the first things we'll do. So first things first, we think that the donations from men have more variation than for women. So in this case, what we would say, the null statement is the variation for men is less than or equal to the variation sigma squared for women. And our alternative is going to be the variation for men is greater than that of the variation for women. So those are our hypothesis statements. So we've got an upper tail test here. And we want to then identify degrees of freedom in the numerator and denominator. And so in this case, the numerator, one group, the men, and the other group, the women, they're going to comprise the numerator and denominator. In this case, we have kind of written over it here, but you see there are 25 of both sample. So our degrees of freedom for both is going to be 25 minus 1 equals 24. 25 minus 1 equals 24. So numerator and denominator alike have the same degrees of freedom. It's not always that way, but in this case it is. Okay, so now we want to identify the critical value for alpha of 0.05. Okay, so let's take a closer look over here at this slide. And we want to, we have a one-tail test, not a two-tail test, so we're looking at this rule here then. Consider the alternative hypothesis. Place the numerator of the sample variance for the population that is predicted to have the larger variance. Okay, so in this case, the men, if we look back at our alternative statement here, right here, the men were expected or were thought to have a higher variance in the alternative hypothesis statement. So the men will be in the numerator, women will be in the denominator. And this is something you'll have to look at with each problem you do, but just know what the rules are, and then you'll know which to put where. And the reason that matters is to get our our alpha value for F. So we'll go back to our table here, and in the numerator is here, and so we have 24 for our degrees of freedom, 24 here, meaning our value for F is going to be 1.9838. So F of alpha is equal to 1.9838. Then, if we want to say the decision rule for that, which I think was the next part of the question, was if the test stat F is greater than 1.9838, reject the null, otherwise do not reject. Alright, so far so good. We are all the way through part E, and now we need to calculate the test statistic. Okay, and this is where that numerator-denominator thing comes into play again. So let's take a look back up here, and we're going to be using this equation right here to calculate our test statistic. So we need s squared of 1 over s squared of 2. 1 and 2 will depend on which you put in the numerator and denominator. In this case, we have the men in the numerator and the women in the denominator. And we have here the values for s, and we will have to get the values for s squared, which is easy to do, of course. We just have to remember to do it. So then our test statistic is going to be f equals 250 squared over 1.34 squared, right? So again, just remember s is our standard deviation, s squared would be the variance. And those are the terms we're working with here. So then we have 250 squared over $1.34 squared, and the result of that is 3.4807. So that is the result. Now, going back to our question, what else do they want to know? Okay, based on our calculations, you can or cannot conclude that the two variances are equal. We would say, again, thinking back to our decision rule, if I can bring that back on the screen here, if our test statistic f is greater than 1.9838, reject the null. We got a result of 3.4807, so we are going to reject the null. And if we reject the null, we cannot conclude that the two variances are equal. In this case, we're saying, in fact, the variance for the men's donations is more variable, that it's not equal to that of the women.